Hello everyone, and thank you for joining us today for our HashiCorp webinar, where today we'll be discussing controlling cloud costs in the retail sector with Terraform. My name is Connor Beechnell, Senior Field Marketing Manager here at HashiCorp, and I'll be your moderator for today's session. And today I'm joined by Andre Pimentel, who's one of our finest solution engineers, and he'll be your presenter today. In terms of the agenda, Andre will start with a presentation before getting into a demo, and after around 45 minutes, we'll wrap up for a live Q&A session. If you do have any questions throughout the presentation, please post them in the Q&A box provided, and we'll answer those at the end. Lastly, please note that this webinar is being recorded, and we'll share that with everyone via email after it's been processed, usually within a day or two. So with that, over to you, Andre.
Thank you, Connor. Morning, everyone. Yeah, so today we're going to do the webinar for controlling cloud costs in the retail sector with Terraform. Let me introduce myself. So yeah, my name is Andre Pimentel. I'm a solutions engineer for HashiCorp. I'm born and raised in Brazil. I'm living in Wales, in Cardiff. I moved here for a year now, but I was living in London. Yeah, sorry if my accent is funny because, yeah, I'm from Brazil. I learned English in Canada, so long story. And yeah, when I'm not terraforming, I'm doing Candle. So yeah, that's me. So today's agenda, we will explore a bit of the workflow of Terraform Cloud and Enterprise. Then we'll take a look at cost estimation. And then how can we leverage the cost estimation with Sentinel and policy testing? So we also see some policy sets, and also how can we have this another layer of governance on Terraform Cloud and Enterprise. And then there will be a couple of links for the foundation on policy. So yeah, I'll show you guys that. So please stay tuned. And then there will be a practical demo. And yeah, as Connor mentioned, there will be the Q&As after. So yeah, this is a pretty informal talk. So I'll start doing some whiteboarding on the Q&As, and feel free to ask any questions. So yeah, that's it. So let's talk about workflows. So let me open my sketchbook here and let me draw a bit. So let's talk a bit about workflows. So in Terraform open source, we have the CLI, right? So everything is pretty CLI centered. You have this very, very tight workflow of coding, Terraform plan, Terraform apply, and you see that you have this very tight workflow here. Then after you do Terraform apply, you end up with a state file. And that's it, right? So the CLI is not easy to automate. So pretty much people try to kind of build their own solution around it using CI/CD tools, using pipelines, and etc. Right? And then several questions come with that, like how do you manage the sensitive variables? Do you put that in the same machine that the client is running? Do you put your variables in the VCS? So yeah. Also, how do you manage the state file, right? The state file is there. If you lose the state file, pretty much that's it. And there's nothing else the client offers since just Terraform open source, right? So people try to build their solution around it. They try to use another policy as code such as Azure policies and etc. And we'll see the difference later about these other solutions to Sentinel. And that's it, right? So you see that for open source, things are pretty much CLI centered. So yeah. And then as you scale the usage of Terraform, a lot of challenges come, like how do you enforce provisioning best practices? How you also onboard different teams to Terraform? How do you enforce your security policies? And also the compliance requirements. And what's the process for auditing? Like if you run Terraform open source in the CLI, yeah, how do you know who did what, when, and where? Okay, and then to solve these challenges, there's Terraform Clouds and Terraform Enterprise. In the terms of use cases that we are exploring today, they're pretty much the same. The main difference now is the architecture. So Terraform is a SaaS offering, and Terraform Enterprise is a private installation of the project. So you own the installation, you also install, configure, and customize Terraform as you want. So to solve all these questions, Terraform Cloud Enterprise, they come up with the concepts of workspaces. A workspace basically is a Terraform project that we centralize the variables. We can encrypt the variables. Also, the state file is centralized by the platform, made high available, so you never lose the state file. Another thing you have is an audit trail. I'll explain the audit trail in a second. And the last thing is role-based access control. So who can access Terraform, who can actually trigger a run, who can apply a run, and also override policies, and also who can see the state file, right? Because the state file in open source contain all the variables, but here we can, the state file is encrypted at rest and in transits, but also we can have the role-based access control to see some information in the state file, such as just the outputs, or in a very admin scenario to kind of see the whole state file and maybe even write the state file that's being hosted in Terraform Cloud and Enterprise. Another thing is that the Terraform Cloud Enterprise offers an API, a full API, so to automate Terraform runs, to adapt it to your current environment, to call it in any CI/CD platform, it's pretty easy. So we pretty much abstract all this complexity. And the consequence of that is that Terraform Cloud Enterprise is very VCS centralized. So everything comes from the VCS, the source control. So there's a one-to-one relationship to a workspace to the VCS. And now, as the VCS is the source of truth, any change, any pull request on the VCS should impact the Terraform workspaces. And we will explore that in just a second in the slides. Cool. So let's jump back to the slides. Enough whiteboarding. So let's talk about cost estimation, right? We'll see the workflow later, but let's see what is cost estimation. So cost estimation gives you visibility, a preemptive visibility of what's going to be provisioned, and also an estimation of the costs. I will show you the workflow in a second. So cost estimation happens just after the plan phase. So the plan phase will check the consistency of your Terraform codes, the dependencies, and etc. And then there's the cost estimation. According to everything that it's on the, came up from the Terraform plan phase, we do an estimate of the costs. Okay. This will give you building sites in first rules before provisioning. The cost estimation will give you a visibility of the costs, but we can leverage that using the policy as codes, which happens in the next phase. And you see that there's a couple of policies that we have using the Sentinel framework to have automated compliance around these costs, right? And it's pretty easy to not only, if you are in a multi-cloud scenario, not just see how would that look like in Azure, how would that look like on GCP, but also how would that cost on these other cloud vendors. You know, cloud vendors, they're different, they're better at different stuff, but also the costs are pretty different. So we'll see that, and now also that will probably give you a visibility of that POC you guys have in the corner, like, oh yeah, how would that project look like on GCP? Is that cheaper? Is it more expensive? Risks? So yeah. And for each resource, there will be an hourly and monthly cost shown. Also, there will be a logical breakdown of some properties that you pay for the resources. I will show that in the demo. And also, there will be a monthly delta. So if you run Terraform from zero, there will be the total cost of those resources. But then as you evolve the codes, as you add more resources, you change properties, let's say in a VM, Terraform in the next run will show also the deltas, like, oh yeah, they will cost more, they will cost less. So that also something Terraform can do, because from the state file, we can see the costs of before, and with the cost estimation on the run, we can see the cost after. This is just an estimate. This is based on the Cloud Vendor API, right? On Terraform Enterprise, you can actually have your own cloud keys to kind of consult the Cloud Vendor API. And some resources, they don't have cost information available. First, because they're free, right? Or they are this kind of a pay as you go, like it's not spot on price we can explore now, but in case, let's say, as a KMS, as you host keys there, you pay more. So this pay as you go, of course, we unfortunately can't estimate. This is very useful to operators who are always interested in speculative plans and compare changes. So you see about how the workflow also offers us this capability of visualizing speculative plans and also to compare changes across workspaces. And cost estimation now supports Terraform resources with the three major cloud providers. Here's Terraform Clouds, but it's Terraform Cloud Enterprise. We can estimate costs in AWS, GCP, and Azure. There's more to come. It's on the roadmap, and soon we'll have some custom cost cloud providers and some other external resources. But now we have these three main cloud providers. To enable cost estimation Terraform Clouds in your organization, you just tick a box on the settings, and cost estimation will start working on your whole organization in all workspaces. For Terraform Enterprise, it's a bit more complicated because you have to create, we actually recommend you to create a set of cloud keys with just IAM permissions into the pricing API. So this is the AWS example. Oh yeah, on the interface, if you scroll down, you see the same example and also the information for Azure and GCP. But on Terraform Enterprise, you can actually create your own cloud keys with just a granular permission on the pricing API, and that's it. Okay. Also on Terraform Enterprise, as you control the infrastructure, your cloud keys are there. But also as you have several organizations, yes, you can enable also the cost estimation in a specific organization and others not. So let's talk a bit more about policy as code with Sentinel. So we saw the difference between open source and Terraform Cloud and Enterprise. We saw the cost estimation, what it is, and let's talk about the policy as code with Sentinel. By the way, this workshop is not centered in Sentinel, but as you see, we have extensive documentation. We have the learn tracks, and I'll show you some examples of Sentinel here. Sorry if that's a bit overwhelming to see Sentinel, which is a bit more different from applying HCL. But if you see our docs and our learn tracks on learn.hashicorp.com, you see that Sentinel is pretty similar to HCL and pretty easy to learn. But as we have the foundational policy libraries and the governance repo, you don't actually have to kind of even code your own Sentinel. You can kind of reuse the policies that we have from the CIS. So yeah, we'll see that in a second. So what's policy as code? So Sentinel is a policy as code framework from HashiCorp, which treats your governance and security policies as an application. The policies are stored in a version control, they're reviewed, and they are automated during your deployment process. Managing these governance adherence as policy as codes will ensure automatic validation. So in the kind of open source scenario, when you're doing a pull request or you're merging your branch to master. Usually to check codes, you open a pull request, you poke your colleague to the back. Oh yeah, can you check my code, please? Can you do a quick check on my pull request? The other person will manually analyze your codes. It's still prior to human error, or they'll probably say, oh yeah, that's Andre. He's so annoying. Let's approve the pull request. And yeah, that's it. So not very good. Also doesn't scale well. So let's say it's me and my colleague, but about teams or multiple teams? What if you have 100 pull requests? Do you manually analyze all the pull requests? So that's also not very good, right? So with Sentinel, we automate this process. We ensure that the policies are going to be run. And also they will happen, as I'll show you the next slide, they will happen before the apply phase. That's very important. So that's the Terraform Cloud and Enterprise workflow. We have the Terraform infrastructure as codes, changes in the VCS, you're evolving your code, you're evolving your infrastructure. That will be next, the Terraform plan and cost estimation phases, right? And then there will be the Terraform policy check phase. You see here, the Terraform apply phase happens only after we are happy with the previous phases. So on the case of Azure policies, the native policies the Azure offers, they will happen at deployment time. So as you're deploying your stack using ARM templates or whatever, if your VPC deployment passes, but let's say an example, your VM deployment fails because there was a policy breach, you actually deploy your VPC. So that's why this deployment time policy as code from other cloud vendors is not very good, because if you point external resources to that infrastructure, yeah, maybe you have a problem. And also you have a kind of a half deployed stack just floating there. So that's also not very good. On Terraform Cloud and Enterprise, the apply will only happen if we are happy with the policy check and the plan and cost estimation. Another thing is the VCS connection. Do you remember when I told you that the workspace relationship is one-to-one to VCS? So as we create a workspace and we set the integration for a VCS, Terraform creates webhooks. So every time we do a merge or every time we open a pull request, Terraform will run doing speculative plans. These plans are not meant to be applied, but they are checking not only the consistency of codes with the Terraform plan, but also the Sentinel phase will run in a speculative plan. So let's say this is my VCS, and as I did a merge here, Terraform ran. And then there will be the checks. So you see here we have the Terraform plan phase and the Sentinel check also here. So we always are gonna assess the plan and the policy check as we do merges or we open a pull request. This is very good to capture risks and inconsistencies in very early stages of development. So as we are developing our infrastructure using Terraform, we do merges as we go. In early iterations, we can capture these risks and inconsistencies. So we mitigate that risk of, yeah, we are Saturday nights eating pizza there. Everyone, yeah, let's do the deployment to production. Everyone is ready. Midnight, yeah, we flip the switch and then something happened, because we didn't capture these risks and inconsistencies in early development stages. So yeah, we kind of mitigate this risk, understanding better how our code is evolving together and if it's actually following the policy check. Also, the VCS connection allows us to target a specific branch or folder. And also it supports all the major VCS providers, Git, GitHub, GitLab, Bitbucket, and Azure DevOps. So let's talk about Sentinel. Yeah, again, this is not a Sentinel-focused workshop. I will show you the links later, but then Sentinel is very easy to understand. The key here is the imports that I'll talk about in the next slides. And the structure is always the same. We have a list of allowed or disallowed properties. We have a filter that comes directly from the imports. The import is a library from Sentinel. We also have a comparison from the allow and disallow property to the filters. And finally, as you see here, Sentinel, by the end of the day, is just a Boolean check, right? So it's very easy to set up. It looks a bit overwhelming, but it's very easy to understand. It's just a Boolean check by the end of the day. And you see here, this major chunk here, the filtering comes from the imports. The Sentinel imports are just libraries, right? You can see them as libraries or modules, and each one of them gives you access to Terraform specific data. So the TF plan provides access to the Terraform plan data. So properties and resources, variables, outputs, etc. Everything that we are changing now. So we actually, if you go back here, we actually filtering the change actions to create or update. So this is new resources or resources that we are updating. We can do the same for destroy. So we can actually disallow teams and people to destroy specific resources or to restrict any property on any resource on creation or update time. The TF states imports provides access to the Terraform state, so existing resource data that we are not specifically changing, but is already there. The TF config imports provides access to the Terraform configuration itself, which providers we're using, the modules we are using, versions of modules, if those modules are from the Terraform registry, if they're internal modules or from the private module registry. Naming conventions, we can also have any reject expression, like to see if a property from a resource, let's say, is compliant to a UK postcodes or any reject expression you can apply. And finally, the TF run imports, which provides access to the data associated with Terraform run attributes, like the organization workspace, and cost estimation. So that's the one we are going to see today. So let's take a look before we jump into the demo and I show you the policies, the policy set. So you see that Terraform codes and Terraform configuration, they should reside in the VCS. So as I mentioned, Terraform Cloud Enterprise, the focus is on the VCS. The VCS should trigger everything, or the API also to automate this process. But Sentinel should also reside in a VCS, should also be in a source control. You see here, there's two lines of development here on the process. So the developers can focus on developing Terraform codes, but admins or InfoSec, any other different teams can focus also on developing Sentinel codes in a different VCS. So as we have another VCS, another repo for Sentinel, is another layer of governance. So specific teams and people can manage that VCS and manage the changes, right? I'm not going to talk about that now, but Sentinel has also a testing platform. So as you develop your Sentinel codes, there's the Sentinel CLI and the mock data that you can actually do automate tests on your Sentinel code before you actually apply them. And to manage that, so the Terraform configuration you manage using the workspace, the Sentinel code you manage using the policy set. The policy sets is also a file in the VCS. So all the policy repos should have the Sentinel policy itself, a file with a .sentinel, and the policy sets is always a sentinel.hcl file. So that file is the key here, because not only we are stating which policies should be applied, but also which enforcement level we are applying, okay? So we have a repo with our policies. We can have 100 policies there, but only the policies that are going to be applied are the ones in the Sentinel HCL file. Okay, this is the file that we state which policies we actually want to be applied, and also the enforcement level. Enforcement level is just a level of enforcement of policies. So advisory enforcement levels only throws a warning. So it's very good if you're introducing a new policy and you're just seeing how our organization is coping with that. Soft mandatory policies is the one that I'm going to show today. Other teams with the elevated permissions can actually override the policies. And also we have the audit trail to see who actually override the policies in the case of a failure. So that is a very classic case of a policy fail, but we are deploying, other people say, yeah, we are fine, so we can override the policy and we can go. And the last enforcement level is hard mandatory. So hard mandatory policies, they will fail. There's nothing you can do, no way to override the policies. It will be a hard failing. Okay, this is kind of the default enforcement level. So yeah, it's like, yeah, that's a failure. Yeah, and good luck on your next pull request. So this is the workflow to manage a policy set. So let me show you in a practical way how is that. I have here my repo. I have 1, 2, 3, 4, 5 policies here. Want to manage the instance size of VMs. So I have a list of allowed types, the T2 micro family, which is pretty cheap. I have also enforce mandatory tags. We have here a list of tags we want to enforce, which are department and billable. So they should be there on all the resources we want to see, and they should not be empty. We have one, that's the policy we're going to explore today, to limit cost by workspace type. I'm not going to show it now because I'm not going to spoil the demo. We have one to validate UK postcodes. So we have here a reject expression to see if a property on resources are compliant with the UK postcodes. And finally, to restrict AWS region, I have here a list of allowed regions. But that doesn't mean anything, because on my Sentinel HCL file here, I have only 2 policies on my policy sets. The AWS instance size, it's a soft mandatory, and also limit costs by workspace type, which is also a soft mandatory type of policy. Okay. I put here soft mandatory so we can show you the whole workflow on Terraform Cloud Enterprise. For the demo today, I'll be using Terraform Clouds. And also you see here we have several workspaces here. But we have the Sentinel policy codes, we have the Sentinel HCL file with the enforcement levels. The next thing on the settings of your Terraform Cloud Enterprise for this specific organization, we have also to assign which workspaces are going to be also set with this policy set. So you see here, I have my under GitHub Sentinel policies is point to my repo. We can enforce a policy set to be applied to all workspaces, to the whole organization, or into a selected workspaces. In this case, is my demo stack, is the one we're going to use today. And we can also pass for this policy sets some specific parameters. I'm not going to show you that now. Maybe on the Sentinel workshop, I'll show you that. Yep. But yeah, what if we have several policy sets, several workspaces? How do we manage that? Do you have to go here as I show you and points and click? Actually, no, because we also have the Terraform Enterprise provider. So to automate your Terraform Enterprise properties and workspaces and everything, you can use the Terraform Enterprise provider. So it's Terraform managing Terraform. So you can use a Terraform Enterprise provider in a separate workspace, and you can control and also make all your Terraform Enterprise consistent. Okay, so as I mentioned, Terraform Enterprise policy sets, policies, workspaces, modules, variables, everything you can also manage using the Terraform Enterprise provider. This is Enterprise and cloud compatible. If you check the docs, you see that, yeah, pretty much you can manage everything on Terraform Cloud and Enterprise. And last, let me show you some links. The first one is the documentation about Sentinel. So we have here detailed information about the imports, how we manage policies. Anything that I discussed today is on the terraformio.docs. Also, if you go to learn HashiCorp.com, you see here that there is learning tracks for all our HashiCorp products, including the new ones, Boundary and Waypoint. So yeah, and on the Terraform learning tracks, we have learning tracks from basic Terraform to use the API to collaborate using Terraform clouds, enforce policies with Sentinel. So everything that I discussed today, and also how can we explore and learn Sentinel is on this learn track here. The Foundation Policies Library is publicly available on GitHub. It was developed by the CIS together with us. And you have here a library of policies from specific cloud vendors. And they have also several examples here from the CIS. So it's a very good place to start. Or, as I'm going to show you, we can just point your policy set to those policies, and we can enforce those policies from the CIS without even having to touch Sentinel. Yeah, and they cover the major cloud providers, AWS, Azure, and GCP. Another place is the governance repo. So yeah, is that the one? No, that's the one, Terraform guides / governance. So here we have from the first and second generation of Sentinel policies, now Terraform 12, 13, and I'm not gonna talk about 14 now, but they use the third generation policies. And you have here several examples. It's an awesome place to start learning Sentinel and to explore policies. You can actually copy and paste policies from here, change the properties, and off you go. We have also cloud agnostic policies here, from the limits costs of our workspaces to other very, very great examples here. Yeah, and also it's a very, very good place to start. So Terraform guides / governance. And as I mentioned, on that sentinel.hcl file, you can actually point the source to any other external repo that it's publicly available. So if you want to use the CIS policies or any policies from the governance repo, you can just point the raw file here, and that's it. You don't have to worry much about coding Sentinel if you're an early adopter. But I really recommend you to centralize that into your own repo, have your teams to manage that repo separately, and to learn Sentinel. So let's go for the demo. So here I have my workspace. My demo stack workspace, as I'm going to show, has a lot of resources. It's pointing to my VCS here. I have here several modules. And if I trigger that from the GUI here, it's just a click, but I could trigger that from the API, because pretty much any functionality we have here, we have on the API, or the way developers work using VS Code should not change, because we can just have this Terraform stanza here, the FSS. My backend is pointing to remote, to this workspace. If I do Terraform plan here, they will actually trigger a Terraform plan on my workspace on Terraform Cloud and Enterprise. So that's very good. So the plan run, yeah, pretty well. And there was the cost estimation here. So the cost estimation, we see we have 12 of 31 resources estimates, because not all of them that we can estimate. As I mentioned, some of them are free, like ingress rules, they're free, etc. Or a couple of them are pay as you go. So yeah. And that's the total cost, because before I did an apply, I destroy my stack. And this is the total cost from 0 to the total cost of my stack. And here we see the breakdown of the resources, the hourly cost, the monthly cost, and the delta. So for instance, if in this AWS instance, I changed the size or any other property, the delta will be the price from a difference from now and before. But if we see here the logical breakdown, we have the amounts we are paying for storage and for CPU. So it's a logical breakdown we see from the costs. The same for the load balancer here, right? So if we go, oh, there's a KMS key. Yeah, I'm paying this for encryption key. So 19 of 31 resources cannot be estimates because, as I mentioned, a couple of them are free or they are pay as you go. And that's the total cost of my deployment, $777.13 a month. After that, we have the policy check. And you see here the policy check soft fail, right? And applies to spending. So we didn't apply anything, nothing is deployed. So let's take a look here at my policy check. I am evaluating 2 policies. So if you remember on my Sentinel HCL file, I have 2 policies here and they are soft mandatory. So yeah, that reflects perfectly on my policy check. If you see here also, the feedback we give to the users is very user-friendly. So it's not that, oh yeah, I failed. Yeah, and we have just a red cross there. No, using Sentinel, we can also give very constructive feedback to the users. And as you see here, we have the 2 policies and we have a description. This policy uses Sentinel Terraform import to extract the proposed monthly costs of the current costs. And the proposed monthly cost of $777.1254, which is an approximate value of our cost estimation, is over the limit of 50. So let's take a look at the actual policy here. So limit cost by workspace type. So this is a very good policy that one of my colleagues, Roger, developed years ago, actually last year. So we have here a list of suffixes in workspaces if they are -dev, -qa, -prods. So we can actually have any rejects on our workspace name. And I'm assigning them to my pipeline stages. After that, I am assigning monthly limits according to my pipeline stage workspaces. If it's a dev workspace, I should be able to spend $200, QA 500, prod 1,000, and other, they don't have that suffix, only 50. So if you go back here to my workspace, under AWS demo stack, doesn't have any of the pipeline stage naming convention here. So it falls in the category of other. If I put a -prod here, yeah, that will definitely pass. So this is my policy here. I am using, as I mentioned, the TF run imports. And there are other imports, but I'm not gonna talk about them now. And as you see here, policy check soft fail. Another policy that fails is the instance size, because I am deploying also large instances here, hence this massive cost. And they soft fail. In the case of advisory, we just have the confirm apply check. But here we have the soft policy failing, so we can actually overwrite. Yeah, on the case of a hard mandatory policy, that would just fail. So if I have one advisory, two soft mandatory, and one hard mandatory, if that hard mandatory fails, the whole thing fails. It's like, yeah, if one hard mandatory policy fails, everything fails. So, but then there are two soft mandatory policies, and we can actually override the policy. So here I can actually override the policy check. By the way, I can do this using the API, of course. And that will go into our audit trail. Overriding, if I know how to type, overriding the policy check, and I override the policy check. Cool, so that's on my audit trail. But then I still need the apply confirmation step. As you run Terraform open source, are you sure you want to deploy that? Yes or no? Here's the same. We can actually do this using the API, but I am using the GUI just to show you that we can do that on the GUI here. And if I know how to type, applying changes, they will also be on my audit trail. Here, as I'm admin, I did everything myself. But in a real scenario, there will be different teams, different people with different privileges. Since I'm admin here, yeah, I did everything by myself. And now that I'm happy with the plan, happy with the cost estimation, happy with the policy check, things are rolling. I'm doing the apply. So nothing gets applied if I am not completely happy with my apply phase. So yeah, that's it. Another good thing is talking about audits. On the runs, I have here all the runs from my workspace. If I check older ones, I think a couple of months ago, my colleague Johnny, he tried to destroy my workspace, but yeah, that's too old. Sorry, I was going to show you that. But I can actually queue that using the API. So if you see here, my run list shows from the GUI the last 50 or 100 runs. But from the API, we can actually access audit trails from the start of the creation of that workspace. Another thing we can do from Cloud Enterprise integration with Splunk. So that will give you logical and very good insights using the dashboards from Splunk. So yeah, check our Terraform Cloud Enterprise Splunk integration, also pretty good. But before we go to the Q&A, I really recommend everyone to check the Learn platform from basic Terraform to the Sentinel tracks. There's also very other good learning tracks to inject secrets with Vault, to use the API. So everything that I did today, from creating policy sets to trigger runs and etc., you can do with the API. And to manage Terraform, to have templates of workspaces with the role-based access controls, and also to check the consistency of your organizations, the Terraform Enterprise provider is a very good place to start. And yeah, another thing is the Terraform Foundational Policies Library, and the Terraform governance folder on the Terraform guides is also an awesome place for you to start. So yeah, that's it. Connor, can you conduct the Q&As? Can we start the Q&A session, please?
Absolutely. Thanks, Andre. So we had a couple of questions coming through, and I'll just start from the top. So the first one is cost estimation going to support other providers such as VMware?
That's a very good question. So cost estimation is a brand new feature. It came around last year on the GA. Yeah, we are evolving cost estimation now. So we have on the roadmap plans for doing cost estimation in other cloud vendors and even on-prem with a custom pricing you can affix to your on-prem resources, and also paid external providers. That's definitely in the roadmap, and in the near future you'll see some great changes in the cost estimation.
Awesome. And the other question we had was, can Sentinel check external sources like APIs or other ITSM tools to query remaining budget for cost estimation?
Yeah, that's also another very good question. So if you check our Sentinel documentation page, which is, you see that Sentinel can actually do external calls from APIs using HTTPS methods. So if you need to check budgets, like how much this team is still allowed to expend, to check all the ITSM ticket status, like we have on ServiceNow approval or something like that, a green tick somewhere that we need to check using the API. Sentinel can definitely do an external check using a HTTPS API call. So to check how much that team is allowed to spend, we get a return of that API call, and we actually use that on Sentinel. To check if we have approvals, any external source properties, Sentinel can definitely check using this HTTPS call to external sources. So yeah, I'm not sure where is that here documentation page, but yeah, we can do that.
Amazing. All right. So thanks a lot, Andre. And with that, as Andre mentioned, if you do fancy learning more about HashiCorp Terraform, then I really encourage you to check out our online learning platform where you can try some of these great features for yourself. And you can find that at learn.hashicorp.com/Terraform. And lastly, just a reminder that this webinar was recorded and we'll make that available on our website after it's been processed. I'll send you a link via email as well once it's ready later this week. All right, so with that, I hope you enjoyed today's webinar. Thanks so much for joining us, and we'll see you again soon. Thanks, everyone.
Thank you, everyone. Bye.